Good morning, everyone. This is lesson 1 of the new unit. We are on page 149 in your AKS book. This is called the Pythagorean Theorem. So I'm going to read this part right here. It says, in a right triangle, and you know a right triangle has 90 degrees, the square of the length of the hypotenuse, and we will talk about this word in a minute, is equal to the sum of the squares of the lengths of the legs. Now, these are considered the legs. This one is considered the hypotenuse. The hypotenuse is always the longest length. Okay, so let's look at the squares here. This square has 16 units. How do I know? 1, 2, 3, 4, 1, 2, 3, 4. This one has 1, 2, 3, 1, 2, 3. That's 9 units. And this one has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 5 times 5 is 25. Okay, so how this works is, let's go back to this square. This square has a length of a base of 4. So we'll put a little 4 there. This height is a length of 3 because there's 3 units. The hypotenuse is 5, and we'll put a little 5 there. So I've got a height of 3, a base of 4, and a hypotenuse or a slanted line of 5. Now let's look at the formula here. A lot of times you're trying to find out what the hypotenuse is. You're not given this part right here. Or you could be missing one of the legs and you're given other two sides. So let's say we're missing the hypotenuse and we know these two. We're going to start plugging the 4 and the 3 in. Now it really doesn't matter which number comes first because you're adding it. Okay, and that's going to equal, we know this is 5. We're trying to prove this theorem, so I'm going to put 5 in here. Usually we're missing this part right here, but we know it today. So we're just trying to prove to see if this theory works. So, I messed up right there. That should be a 2. So let's use our exponents. 4 to the second power is 16. 3 to the second power is 9, and 5 to the second power is 25. And if I do 16, add 16 and 9, that gives me 25. So the theory does check out. That is a right triangle right here. If it did not check out, this would not be a right triangle. Okay, so that's the theory. Let's go to some practice problems down in the bottom. Okay, now let's look at this triangle, because this triangle is shaped a different way. It's kind of pointing downward, but you have, this is your height, this is your base, this is your hypotenuse. Now the hypotenuse is always opposite of the right angle. Pull that down a little bit. So we are missing the hypotenuse, which would be your C in your formula. I'm going to go ahead and write the formula out. So we're missing this part right here. But we know A and B. So let's just go ahead and plug A and B in. Don't forget the square. I'm going to put the 7 in the A, and I'm going to put 24 with B, and we're missing C. So that's how you plug the formula in. 7 into 24, your A and B. Your C is always opposite of that right angle. So knowing our exponents, and we'll probably be using the calculator on this. Oh, and that is C squared. Okay, now watch right here. This is just like an equation. I'm going to go ahead and add these numbers. That's going to give me 625 equals C squared. Now, here we go. We got to find C. Now, we can't just say C is 625 and just put that where the X is. This says C squared. So remember back with our square roots, to get it to C, we have to square the 625. Okay, so the square root of 625, I'm going to reverse it. So C equals 25. So that X is going to be 25 back up there. And notice the 25 is higher than both of these numbers. On a right triangle, that line, that hypotenuse or that line opposite of the right angle is always going to be higher than these two. Okay, let's go down to, actually, let's go to B right here. Let's notice again, this is our C. Why? Because it's opposite of the right angle. So these are my A's and B's, so let's plug it in. I'm not going to write out the formula again. I'm just going to write out plug the numbers in. Okay, so there's our formula. There's my A and my B, and we're missing C. So we have to square both of these numbers. And then the next step is to add them. Now we got to take the square root of 74. Now going back to our flashcards, the square root of 74 is not a perfect square. So we would plug that in the calculator and it would be a decimal. So C is going to equal 8.6. Okay, so that is going to be right there. Is 8.6 higher than 5 and 7 or longer than 5 and 7? Yes, it is. Okay, so this time we did not get a perfect square, which is okay. Okay, let's go to the ones in the bottom here. Now, this is going to be a little different. Let's look at this shape. There's our A and our B. This is our C, but this time we are given the C, and we are missing the A. So, or the B, you could say that's A or B. So here's how I set it up. And like I said, it doesn't matter which one's A and B. So I'm going to put 10 for A. I'm going to say we're missing B. And this 20, this time is my C because it's opposite. A, B, C. All right, let's just go down. We don't have a lot of room down here. So that's 100. I'm going to bring down the B squared. 20 squared is 400. Now let's stop right here. We need to find B. We've got this 100. Going back to our equations, we have to get B by itself. So going back to our equation unit, that unit's coming back to help us with the Pythagorean Theorem. So we have to get rid of 100, and then I have to do it on the other side. This becomes 300. This cancels, and I have to put my B squared back in there. So let's take a look at it. I still, at B squared, I have to take the square root of 300 to get B. And I do that. That's not a perfect square, but it's going to be 17.3 is going to be, now take a look. 17.3 is going to be my X. So it's going to be my base. Let's notice the other numbers. That 20 hypotenuse, or opposite of the right angle, is still higher than my A and B, even after I solved it. So this one was a little bit different because you were missing one of the A or the B, and I said this was B. So you have to kind of work it backwards. All right, I divided this one up. Let's look at the last one. This one's kind of slanted, but you're missing this base again. This is your C, so you are given the C. I'm going to say this is B. We're missing B. So let's plug it in. A is my 5. I'm missing the B squared, and my C is 13. Now don't forget, on C you have to square it. Sometimes I see students just put a 13 and forget to square it. So let's run through our exponents. And 13 times 13 is 169. Again, you have to get B by itself, so we're going to subtract 25. $169 minus 25 is 144. I like that 144. You should too, because it's a perfect square, and B is going to be 12. So let's make an arrow. There's our B. It's 12. Still, 12 and 5 is lower than our hypotenuse, so that works out. Okay, and to check yourself, I didn't go over this too. Just check yourself to see if you're right. You can plug B back in here and then square them and see if it equals that 169, and it will. Okay, so those are your practice problems. We're going to go over here to the other side and do the converse. Now, I don't like to read the converse because all it is when you're given 3 sides, You need to prove that that is a right triangle. It does not have the little box here, and it's hard to tell just by looking at it if it is, and there's a way to do it. So basically, we're just going to plug in the numbers. Now, here's the key. I'm going to go ahead and write the formula down for the first one, is to figure out which number on your triangle goes in the C column, because it does matter which one goes here. It's always the highest number. There's my 17. These numbers don't matter. I'm going to put 8 squared here. I'm going to put 15 squared here. And then that's 17 squared. All I'm going to do is just solve these square roots. I'm not square roots. I'm just going to square these numbers. 17. We'll use a calculator on this. 17 is 289. And then I would add these two. Excuse me, and when I do, I get 289, and that does equal 289. Now, what does that mean? That means, yes, this triangle is a right triangle. Okay, so that proves that that is a right triangle. Let's go to B over here. Again, we've got to get our numbers in order. There's my C. So I'm just going to start plugging it in. I'm not going to use the formula over here. I'm just going to kind of plug it in from here. I'm going to say this is 9 squared plus 24 squared equals 25 squared. Numbers are getting larger, so we're going to use the calculator again. This is 81. 24 and 24 is 576. And 25 times 25 is 625. Again, we're going to add these two, and when I do, I end up with 657, and that does not equal, obviously, that 625. So this is a no. What do I mean by no? It's not a right triangle. I'm going to put yes here. Okay, so that one proves out correct. This one proves out not a right triangle. Even though it kind of looks like it, it is not completely. All right, we have two more. Okay, key is this. Which one is C? This one is C. And then these are our A's and B's. So I'm going to use this formula up here to start my problem, or to fill it in. Okay, that's how I filled it in. Now we're going to use the calculator to kind of to get the numbers. 529 is 23 and 23, and then 625. And if we add these two, we have 629. We're supposed to see if that equals 625. Obviously that does not, so that is a no. That is not a right triangle. Close, but it is not completely. Okay, one more example. C, this is our longest side, so that is our C. Let's just start filling it in. 28 squared plus 45 squared. We're trying to see if those two equal 52 squared. 784 plus 202. And I just plug these in the calculator. And 53 and 53 is a large number. If you add these two, I did get 2809 or 2809. So what does that mean? Yes, that is a right triangle. Okay, so we went over two different methods of Pythagorean theorem. Trying to find the missing side over here, and then trying to prove if these triangles are right on the right-hand side.